Hello everyone. Today I will be explaining the measurement method of video of our experiment. So because we are using a tracker program, we actually need to calculate a scale for a scale multiplier for our position tracker. So if we actually see here, if the ball here travels around to there, for example, we can't know the actual distance from the tracker itself. As we see here, if we just zoom in and we look over here, the x value here is 30 meters, and here it is around 50 meters. So that's a difference of 20 meters, and clearly it is not 20 meters of difference value. So it is clearly and obviously scaled. So now to calculate that scale, we actually need to get the actual distance, which is this one, and then we get the distance from the tracker from here to here, and then we divide them and we get the scale multiplier. So firstly, let's get the actual distance which we got it as, I think, around 5 meters, but this was our first video, so we changed it a little bit. So let's just assume that this is 5 meters. So here we will put 5 meters, and then the tracker distance, which here is minus 1, around minus 100 meters, and then over here it is around 450 meters. I'm looking at the x value, by the way. So we will calculate the difference value, which is going to be the greater value minus the smaller value, and then we get a difference value of 500 meters. So then, since we will multiply the position we get in the tracker program, we need to divide the actual distance over the tracker distance. This is obviously the case because with dimensional analysis we we transform the tracker distance to actual distance. So we'll take this value divided by this value, and this is the scale multiplier. So for example, if we take this table, we copy it and bring it to Excel, I will transform this to normal looking numbers so it's very clear. So we see here, this is the tracker value. So if I want to transform into actual distances, I just do this, take this value multiplied by the scale multiplier, and this is the actual position, actual real life position, and we just drag it down. Hold on. Let's just do this. So yeah, we get the actual real life position of the ball, and then if we want to calculate the actual range, we just do this minus this. But if we see here, this is not really the case, because the starting launching height value should be the same as the landing value. So this is clearly not the same. So the ball actually traveled like this. We do not want this part. This is wrong. So we will only take this value. This is what we want, because the range is defined as this. So we approximate. This is the starting y value. We take it. I believe that this is this or this. So I will just pick this one. So rather than picking the final value, we pick the corresponding value, which is 1.2, or the other way around. And this is the actual range. And for the height, it's very simple. We just take the maximum height. First, we need to transform it, which is just the same way as we did for the x position. We drag it down, and this is. And to get the height, we just take the maximum height value, which is this one. You can see it by comparing by the ones in between, minus the first value, and, we'll get the maximum height that traveled. And we're just going to compare it with the simulation results and then validate them with the mathematical model. And that's it. Thank you for watching.